Hello, hi, welcome to the exercise 1, question number 3. So we were going to look on the mixed strategy Nash equilibrium. Sebab hari ni baru kita habis belajar mixed strategy, so kita akan tengok balik question number 3. Okay, let's look on the question. An embezzler wants to hide some stolen money and inspector is looking for the stolen money. There are two places the embezzler can put the money, either difficult or easy to access. The inspector has a time to look in one of two places. It's more costly to hide the money in the difficult place than the easy place, and also more costly for the inspector to look in the difficult place than in the easy case. The payoff are as follow. If the embezzler hides the money in the difficult place and the inspector look in the difficult place, the payoff will be 0 for the embezzler and 2 for the inspector. If the embezzler hides the money in the difficult place and the inspector look in the easy place, the payoff is 2 for the embezzler and 1 for the inspector. If the embezzler hides the money in the easy place and the inspector look in the difficult place, the payoff will be 3 for the embezzler and 0 for the inspector. Finally, if the embezzler hides the money in the easy place and the inspector look in the easy place, the payoff will be 1 for the embezzler and 3 for the inspector. Okay, first question. We need to determine is it the fact is true or not. If they are saying that if the inspector believes that the embezzler randomized using my pointer, randomized it choosing hiding places and hides the money in the hard place with the probability 2/3 for embezzler, and the inspector will maximize its expected payoff by looking in the hard place for probability 2/3. So we want to justify is it these words are true or false. So first of all, what we do, we convert we convert the equation here, the given sentences here into table like this. So we'll be have inspector and embezzler, easy and difficult, and previously they already tell that if embezzler had with probability 2/3, definitely here will be 1/3 because 1 and 1 minus p, and here is 1/3 and 2/3. So first of all, we just calculate using mixed strategy. So 2/3 times 2/3 and 2. I start from behind, you can start from in front also, you will still get the same answer. So we get 13/9. Okay, next, because we want to know the inspector will maximize the payoff if it looking the hard place of 2/3. So if the inspector looking at the hard place for 2/3, so for this case what we do, so we make sure we use the same table. For embezzler, we still put 1/3 and 2/3, while for inspector now we change because we want to know is it true or not. So we make it if inspector finding in the easy place, the probability will be 1, and if the the inspector looking at the difficult place, the probability will be 0, because here they mention the inspector will maximize expected payoff by looking at the hard place with probability 2/3. That's why I put here 0. So next, using the same equation, so let's say I start from behind, 0. Okay, let's say I start from behind, 0 times 2/3, 0 times 2/3, 2/3 from the difficult, times with the payoff value 2, plus 0, go to the difficult, still go to the difficult, 0 times 1/3 times 0. Okay, and you do the same thing, and finally you get the answer is 5/3. If you look the value, 13/3 is 1.4444, 1.444, while 5/3 is 1.6666. If you look that, these show the payoff of the inspector could be further increased. Correct? Because previously when put 1/3 and 2/3, you get 1.44, while when I'm putting 1 and 0, I get 5/3. So it means that the payoff of the inspector should be further increased if the inspector chooses the pure strategy to look in the easy place instead of the choosing the mixed strategy to look in the hard place for the probability 2/3. So the justification here is false. Let's look for the question number B. Okay, in question number B, they ask us find a Nash equilibrium in mixed strategy for this game. So first of all, you just take back let me use the pointer again. Okay, first you use back the same table between embezzler and inspector, but now rather than you put the value, because in this question they ask us to find the mixed strategy. So as usual, we put as PE, it means the probability of MZilla, and 1 minus PE, PI, probability of inspector, and 1 minus PI. So first of all, let the probability of the MZilla hiding the money in the place is PE. Is PE if it is easy place, and hiding in the hard place will be 1 minus PE. Okay, then the expected payoff for the inspector when looking. So now is already I think all of you already understand how we should do on the mixed strategy. So the expected payoff for the inspector when looking at the easy place. So when looking at the easy place, actually we referring for this column, and if you are referring for this column, it means that we will take the 3 PE. 3 PE plus 1, the second value 1, and 1 minus PE equals to 2 PE plus 1. This one I think easy, right? So next, the expected payoff when looking the hard place. So look at the hard place. So when inspector looking hard place, it means that between 0 and 2, it means that the same property PE times 0 plus 2 times 1 minus PE equals to 2 minus 2 PE. And we know when it's called mixed strategy, it's randomizing between two strategy. So that's why we need to mix as equal. So this one you can look from the previous lecture notes, today's lecture notes in the part 4. Okay, and when you make it equal, you get PE equals to 104. Definitely if this PE equals to 104, 1 minus PE should be 304. And now we use the same procedure to find the probability for the MZilla. Okay, when we look, okay, if we look back here, when we look for the MZilla, okay, when we say that MZilla are playing the easy places, so it means we will look on the expected payoff for inspector between easy and difficult, which is 1 and 3. So we're using the same formula, 1 PI plus 3, 1 minus PI equals to 3 minus 2 PI. Then the same goes for the when is hiding place in the hard place, 2 PI plus 0, 1 minus PI equals to 2 PI. And next, make sure you equal that value, and finally you get 3 or 4. So it means that here you got 3 or 4, and here we got 1 or 4. It means that the MZilla chose to hide the money in the easy place with the probability 1 over 4, and choose to hide the money in the hard place with the probability 3 over 4. While the inspector chose to look in the easy place with probability 3 over 4, and choose to look in the hard place with probability 1 over 4. Clear, right? Okay, so next, look on they're asking us what is the Nash equilibrium, and what is the expected value for the MZilla, and what's the expected payoff for the inspector, and finally what is the probability that inspector find the money. For this case, okay, we already convert everything to the value that I already get just now. So next is easy, you just do accordingly what we learned in the previous lecture on how to calculate. So first of all, the first step, we just times the value here and put here, like 304 times 104, 316, and you do the rest as same. Next, what you do, if you want to know the MZilla, let's say A is the MZilla, expected Nash equilibrium payoff, we just take the value and times with the value, and you will get both of them will get 3 over 2. Okay, so finally the question is the last one, what is the probability that inspector finds the money? So inspector can find the money either easy place, MZilla easy place, and inspector easy place, or difficult and difficult. Correct or not? Okay, either find in easy and easy, or difficult and difficult. So it means that 1 over 4 times 3 over 4, easy and easy. Another one is 3 over 4 times 1 over 4. Okay, still easy place. It means the inspector can find the money. That's why you get 1 over 4 times 3 over 4 plus 3 over 4 times 1 over 4 equals to 3 over 8. So it means that MZilla either put in easy or difficult, we still can find the money. Okay, that's all for the question number 3. Thank you.